Hello everyone, welcome back once again. I hope you all are fine. And today we will learn about special functions by Scipy. It is our fourth class of Scipy tutorial. I hope you have revised my previous classes, and if you have any queries, I'm repeating again, you can send them on my Instagram, or you can just mail me your queries, or you can also write down your questions, your doubts in the Facebook page. All the links are provided in my YouTube channel. And someone has asked me repeatedly that whether I am going to delete all these videos from YouTube or not. I just don't worry. I want to tell you, these videos will be there as long as the course is going on. This course is about 6 months, and we have started from October. So all the videos will be there for 6 months, and you can learn them at your own convenient time and from anywhere you want to, and you can see them as many times you wish to. Okay, so don't worry, and just concentrate on this learning part. And if you wish to know more of these things, you can just always mail me. I will be happy to help you out. Okay, so today we will do with special functions, and according to Wolfram Math World, a special function is a function having a particular use in mathematical physics or in some other branch of mathematics. Okay, so we will today deal with Legendre polynomial, which is a special function and that can be easily solved in Python using Scipy. Over here, I have written this Legendre polynomial famous equation in blue, as you can see. And the Legendre polynomials of different orders that satisfies this differential equation is like P0 x is equal to 1, P1 x is equal to, this is actually Legendre 1, so Legendre polynomial 1 expression is P1 x is equal to x, which I have written in this format, that is 1 dot x plus 0. Why I have written, I will just clearly explain you when we will proceed with the programming part in our shell, Python shell. Okay, this is Legendre 2, where this P2x is equal to half of 3x squared minus 1. I have rewritten that in this format, like 3 by 2 x squared plus 0 dot x minus half. Okay, and finally Legendre 3 polynomial equation is this, which also can be rewritten in the format of 5 by 2 x cubed plus 0 dot x squared minus 3 by 2 x, and finally a 0. Okay, just note down these equations in your copies, because when we will move on to the shell, it would be easier for you all to understand. Okay, I'm lending you 2 minutes, just write down these equations in your copies. Okay, I'm now moving on to the Python shell. Is my screen visible? Okay, so as I was saying that Legendre polynomial is easily done with the help of Scipy, but we have to import this Legendre from scipy.special. As you have noticed that in case when we were doing with ODE, we used to call ODE int from scipy.integrate. Over here we'll write from scipy.special import Legendre. Okay, this is the basic library that you have to call when you are dealing with special functions. After that, if you want to know about the Legendre polynomial 1, then you'll just simply write Legendre 1 and it'll fetch you the result. I hope you remember our P1x was x. So I have rewritten that as 1.x plus 0. And over here it is showing you that only 1.x plus 0. So it is poly 1D format. Okay. If I wish to see Legendre 2, then also, I hope you remember it was half into 3x squared minus 1, which I have rewritten in the format of 3 by 2x squared plus 0 dot x minus half. So 3 by 2 means 1.5. 0 dot x was square, 0 dot x was there, so it's 0, and minus half, that means 0.5. So I hope you are finding, just check for Legendre 3 what you're getting. Okay. So I hope you are able to now relate with this. Okay, note that this output of the Legendre function is a polynomial and it is given in the format of poly 1D array. So we can extract the coefficients of the polynomial as discussed in numpy. The coefficients are in the order of the polynomial terms of decreasing power. Okay, remember this thing. Okay. So we can also evaluate at any point, like say if I write P3 is equal to say Legendre 3. And I want to know the value of Legendre 3 at all the points of that. So if I wish to know about the coefficients and the points, then I can just simply write P3, and if I write say 0. So it is giving me 0. Okay. If I write P3 and I write like say 1, then it is giving me minus 1.5. Okay. If I wish to know about P3 2, that means it is of this format. So P3 2 will give me P3 2. It should give me 0. Okay. And finally, P3 3 will give me 2.5, right? So P3 3 should give me 2.5. Are you following, everybody? Okay. So it's like this, we can also reconstruct the polynomial of the order of 3. So this is the basics of Legendre. It is very, very easy to solve Legendre equations and polynomials and find out the values using this scipy. Now, if you want to see the plots and all, just move on to the Spyder shell and we will write down the entire program now and you'll see how the plot turns out to be. Okay, so moving to the Spyder shell. I hope my screen is visible. Okay, if you have any queries, just let me know. Okay, so for Legendre polynomials of various orders and plots, we are going to do this program. So just first write down the name of the program. So we will do Legendre Polynomials. Okay. And we'll be doing using scipy.special and importing Legendre. Okay. Solving using Legendre. Fine. I hope it's quite visible now. Okay, so you have to import Legendre. So write down from scipy.special import Legendre. This is the first thing you have to do. In order to see the plot, you have to import Matplotlib.plot as plt. These are the import sections. Then you have to give the values of x. So x is equal to, I take an format of a range, okay? So a range -1, comma 1, and say comma 0.01. If you have forgotten how to write with the A-range thing, just go back to the video of my numpy section and you will get to know all this in details again and revise that part, okay? Next, is it okay now? Okay. Next is we have to define the polynomial. So if I have to write like P1 is equal to Legendre 1, just plain simple in this format, Legendre 1. Then P2 is equal to say Legendre 2. Okay. Then P3 is equal to Legendre 3. And finally, P4 is equal to Legendre. Fine. After that, it is actually the first part is over. Now you have to just mention the plotting part. So I'll write plt.plot, plot of x versus I'll do p1x. Okay, so x versus p1x. Okay, and you can improvise over this. Like if I want to change the line width, I can write LW is equal to say 2 and ls is equal to line style. Okay, line style, say I'm giving as say as dash. Okay, and color equal to say like k. Okay, now I just copy this thing so that is easier. Instead of typing, it will save my time. And again, I have to write this part. So plt dot over there. Okay, I made a mistake. Be careful while you're also writing. So plt.plot x, now I'll write for p2x. So I just change this part, p2x, keep the line width same, and line style, say I make it as double dash, and the color, say keep it as whatever you wish to, I say like R, okay? And similarly, the last part, plt.plot, and over here is like p3, keep the line style different, give the line style different, okay, say like dash dot, and over here say like G, okay? And finally, I'm just giving all these changes because so that you can understand which Legendre polynomial curve is representing which polynomial, okay? For that only. If you wish, you can keep it as your own, whatever you feel like. It will help you to distinguish better. So like B, okay? So I have given all this for plotting section. Now I can give the limit part. So plt dot x limit, keep it as from -1 to 1, and plt dot y limit, keep that from -1 to 1 as well. Plt legend, you can write, it's optional as well, but if you wish, you can write plt dot legend Okay, this is the first one, legend for first one. Similarly, legend for the second one. All the legends complete. Okay. Close the bracket, and this completes your legend part. After that, write the title, plt.title, and I'm naming this as Legendre Polynomial. Okay. Give the size, say, as 18. And finally, plt.show. Okay, so this completes your program, and we will now save the program and see how the output turns out to be. Okay, it is very simple. The program is very small, and it's very useful while doing mathematical functions using Legendre polynomials. So I'll just save my program. So I have saved my program as Legendre Polynomial scipy.py, and I wish to see the nature of the graph. So just hit the run button. There is an error over there. Let us check what error is coming. Which line? Okay, sorry, I haven't imported numpy. So I have to write import numpy as np. I'm extremely sorry I forgot to import as I was explaining. Okay, because we have taken this a range as numpy function, so you have to import numpy as np. Okay, just save the file once again and rerun the program. Are you able to see the program now? The curve has been formed, and you can see the legend is over here. I have the title, and the x ranges from -1 to 1, the y ranges from -1 to 1. And now for P1, like this P1, I have taken as color black. Then this thing, this red dot is my P2, and the blue dot is my P4, and the green one is my P3. So all the graphs are visible over here, and it is showing you the nature of each of the Legendre polynomials. A very beautiful graph. You also work out and show me in the chat box, or you can mail me. If you have any queries, you can send them also as well. I hope you have enjoyed today's class, and I wish to take another class before Christmas. And so thank you all, and stay safe.